Today, I'm teaching you how to use a decision tree to choose which statistical test you should run. In this unit, I'm going to teach you how to use resources to analyze data. This section does not involve memorizing how to conduct these analyses, but does involve memorizing some new concepts and terms. You will learn how to use my analysis decision tree, and that's all we're learning for today. However, later in this unit, you will also learn how to get pattern, p-value, and population effect size, aka the 95% confidence interval of effect size, from our statistical program called Jamovi by following my video tutorials. This section is not about memorizing my tutorials. In fact, I don't want you to do that. I want you to choose the right tutorial and follow it perfectly each time so that you can ensure you're doing the analyses correctly. Deviating from these tutorials at this phase in your analysis career is a horrible idea. Great scientists can follow instructions. So this section is less about long-term memory. However, the more statistical analysis you do, the better you will get. And this section is more about teaching you how to follow a statistical protocol. Remember, all we're doing today is the decision tree, but this is the bigger picture. The test quiz for this section will be for you to replicate my output. I have not posted this yet. Describe the pattern, find the P, and make the better than nothing decision, and convert your 95% confidence interval to the small, medium, and large values. You will put in your own words what you learned from this analysis. I will also teach you how to write up your results in APA style. Again, this is not for today. At the end of each video, I will provide interested parties with more information about each test, kind of like the concepts and engine of that test, but that is optional information. So when you look at this section is about choosing the right test, following a video tutorial, and really understanding PPP from last time. There are a few additional things, like how do you write up a statistical result in APA style, but it's just an extension of what we've been learning. Now, in order to use the decision tree, we must understand the difference between an independent variable and a dependent variable. I use the simplest version of everything. This causes that. Right? This causes that, I causes D. Your independent variable causes your dependent variable. Your independent variable is the cause, your dependent variable is the effect. Now, in true experiments, I can just state it that way. But in correlational designs, I can say, I think this causes that, right? Because remember, in correlational designs, you have to choose what the IV and DV are. Now, some of you really hold on to these traditional IV-DV definitions that worked in 6th grade, but those really only work for true science experiments, and the way they taught it to most of my students appears to be that they only taught you that there's always a control and experimental condition. That's not always true. Sometimes there's a high-low condition. Sometimes there's different dosing conditions. So just let that all go and think the IV causes the DV. The IV is the cause, the DV is the effect. That's all you need to know. Now, the first concept you need to understand is the difference between categorical and continuous variables. Now, when I'm using the word variables, this means IVs or DVs. IVs or DVs can be categorical or continuous for both of them. Categorical just means in general there are different categories. For example, in gender, you have men, you have women, you have transgender folks, non-binary folks, genderqueer folks, right? Categorical in a DV, you can have yes or no questions. A yes or no question is a categorical DV. Your traditional experimental versus control group is definitely a category. And really all independent variables in true experiments are always categorical variables, right? Like they have different categories. So gender is, a categorical variable, an independent variable for most part. Yes or no questions are a categorical dependent variable, and different, like every true experiment IV is a categorical variable. That is just true. Now, continuous are numerical responses. Like you got your basic ones, temperature, heart rate, and all scales, 1 to 5, 1 to 7, 1 to 10. things that are clearly continuous, like percentage, 0 to 100%, GPAs, 0 to 4.0, and so forth. So really, categorical variables are categories, continuous variables are numerical responses. Or they're numerical responses. There are two exceptions that prove the rule. So these are the two hardest things. So you randomly assign participants to drug doses. You got 10 milligrams, 20 milligrams, and 30 milligrams, right? And you're like, oh, well, this is a continuous variable because it's numerical. Well, technically, these do feel continuous, but you always use categorical for IVs. This is an IV experiment. You manipulated this. So this is the exception that proves the rule. Watch out for this exception, okay? It's not continuous, it's categorical because you randomly assign people to this level. It's a true experiment. This is your independent variable, okay? And when I said this level, I meant many levels. Now, in general, it's best practice to use multiple questions when using 1 to 5, 1 to 7, 1 to 10 scales, right? But sometimes we only use one question. Like, for example, I'm happy. 1, strongly disagree. 2, disagree. 3, disagree. 4, agree. 5, strongly agree. This is considered by psychologists to be continuous, and some people critique us for it. All right? I don't care that some people critique us for it. This is what we mostly will use. Also, if you get older and more advanced, you can change this. But right now for my class, we're going to treat all scale values, all scaled variables as continuous. 1 to 5 scales, 1 to 10 scales. Those are continuous, right? All truly manipulated independent variables are going to be categorical as well. The second thing you just need to know is the number of independent variables that are present in an experiment. In this class, we're going to have 1 or 2. That's it. So you can have 1 independent variable or 2. When you propose a moderation or mediation experiment, you have 2 independent variables. See, essentially, the moderator and the mediator is just an additional independent variable. The results will tell us if it's actually a moderator or a mediator, but at the first stage of, thinking about how to analyze it, we don't know if it's a moderator or mediator yet. So it's another independent variable. That might seem a little confusing. Just think about it this way. Moderators and mediators can be thought of as another independent variable. Okay? Now, you do have exceptions to this. Remember the 3 experiments that you run to test, mediation, right? Well, yeah, those are 3 different experiments, 3 different analysis, okay? So when I'm talking about an analysis, I'm talking more about that knockout study, or you measure the IV, the mediator, and the DV all at the same time. So that might seem a little confusing because we've been calling it a moderator. Just know that moderators and mediators, when they are measured or manipulated in the same study as the independent variable, they are a second independent variable. Number of conditions or levels for a categorical variable, that's something else you have to think about. This is not hard. Control versus experimental has 2 levels. 10 versus 100 versus 1,000 milligrams is 3 levels. Men, women, transgender, that would be 3 levels as well. That's very simple. And number of DVs. So in your studies, you may have numerous DVs. You do 1 analysis per dependent variable. But in our tests and in our problems, I'm giving you 1 dependent variable per problem. So for the class learning these skills, you're not going to be tricked by multiple DVs. But on your actual projects, you might have multiple DVs. So I just need you to know that. All right? So every dependent variable that you use is going to have its own analysis. The next thing you have to learn is the difference among a between participant versus within participant design. This only applies to categorical independent variables. Let's start with between. A between categorical independent variable has different people in the different conditions or levels of the independent variable. When you randomly assign participants to a condition, you're using a between design every single time. Another example is if your independent variable is participant gender or participant race or some other participant identity marker. You have a between design because you have different people in different conditions. Within is the exact opposite. You have the same people in all conditions of the independent variable. You're probably familiar with the pre-post design where you measure a baseline response, do something to your participant, then measure something else, then measure this response again. There are many forms of within designs. Another common design is when you have participants rate numerous different targets that differ as a function of your independent variable. In my research, I often have participants make decisions for fictional black and white patients. I'm looking for prejudiced responses, and because each participant provides answers for black and white patients that are fictional, I can assess individual differences in racism. The main thing here is that in a between design, you have different people in different levels of the categorical IV, and in within design, you have same people in different levels of the categorical IV. I think the easiest way to tell if you have a within design is that for each participant, you will get multiple dependent variables from each participant. So if you have two conditions, you will get two dependent variable measures from each participant. If you have three conditions or levels, you will get three dependent variable measures from each participant. So if a participant is giving you more than one dependent variable measure, that is a within participant design. Now, a lot of students ask me, well, when should I use the within subjects design? And there is no right answer. All right. There are things to consider. In my own research, I try to use it within participants design whenever I can. It's because it requires less participants to find significance. And this is because each person is their own control. So you're removing all possible third variables from impacting the results. All individual differences are removed, essentially. Now, we don't want to use a within participants design when there are carryover effects. So that's really the first experience, right? In the first condition contaminates the second experience. So this is like the manipulation in condition 1 will carry over to condition 2. So, for example, in some of my work, I teach participants how to feel empathetic towards someone the first time I measure the dependent variable. The reality is that my participants will probably still be experiencing empathy the second time I measure the dependent variable. I've also used within, like I mentioned before, I've used within participants' designs when I'm having participants judge black and white patients, when I'm looking for racial bias in treatment decisions. But I don't use it within participants' design when I manipulate emotional states like empathy, anger, etc. I just feel like that's too hard to get the participant back to baseline. If I were to teach something that's really effective, like if I teach a memory technique that you can easily use without me seeing you use it first, then what's stopping you from using it the second time, I present, the second condition, right? I don't use it when it gives away the purpose of my study. So I don't use it in participants' design when it gives away the purpose. Actually, in my research with race, where I have participants rate white and black patients, I have had some folks critique that and say they'd rather see it in a between subjects design or between participants design. You might hear me say subjects from time to time. But ultimately, this is just, we can talk about this if you ever come to this. This is a difficult decision to make by yourself. But I always try to use within participants' designs because they require less participants. Now, when you do use it within participants' design, you have to counterbalance which condition comes first. So half your participants in a simple control experimental independent variable, half your participants will be in the control group first, half will be in the experimental group first, right? So the first half will do control group first, and then they'll participate in the experimental group, and the second half will do the experimental group first, and then they will participate in the control group. That's an interesting design. If you think about it, you can always examine participants' first answers as a between participants design, which is an interesting thought. But ultimately, that's a little bit more about within participants designs. If you can use it, you can use it. I'm not going to ask really any questions here other than, is this a within participants design? When to use it? Come talk to me. Choosing the correct analysis is not that difficult. You need to correctly identify all independent variables and dependent variables. There will only be one dependent variable in my problems. But in the real world, you have to know if there are more than one. For your dependent variable, is it continuous or categorical? Continuous dependent variables are things like psychological scales, questionnaires, heart rate, numbers, things like that. Categorical are going to be things like yes or no, alive or dead, pass or fail. You need to know the number of independent variables. Remember, moderators and mediator problems will have 2 independent variables. For each independent variable, you have to know, is it categorical or continuous? For categorical variables, independent variables, you have to know the number of conditions per independent variable and whether or not it is between or within. For continuous independent variables, you just need to know if it's continuous. All right, so we have my decision tree, and this one's might be a little different than yours. I might find some mistakes in it. I'm recording this a little bit early. But my independent variable was money, rich versus poor, and it was between, because I gave that to us. I want to see how to use the decision tree. My dependent variable was happiness as a percentage. So is your dependent variable continuous? Yes, it is. Are IVs are all categorical? Yes, they are. Do I have one independent variable? Yes, I do. Do I have 2 conditions? Yes, I do. Do I have a between participants design? Yes, I do. I run the independent samples t-test. Now, it's okay that you don't know what that is yet, but that is the correct answer. That is the test we run. So for this first part, the problems will get harder, but that's all we have to do is pull out the information and figure out what test we run. All right, so we have a very similar problem. Our independent variable is money, rich versus poor. It is between again. Our dependent variable is yes versus no. Are they happy? So our dependent variable is happiness. Yes. Is your DV continuous? No. Double check your DV is categorical variable. Yes versus no questions. Dead versus alive. Pass versus fail. Yes, it is categorical. Dependent variable is categorical. So now we take the decision tree over here. My IVs are all categorical. Yes. I have one independent variable. Yes. I need to run the chi-square test of independence. Again, it's okay that you don't know what that test is, but that's the test that we run. So in this case, my independent variable is now income, and my dependent variable is percentage happiness. Both of those are continuous. So is your dependent variable continuous? Yes. IVs are all categorical. No.
I only have one IV.
Yes.
Run a simple correlation.
So we're going to run a correlation.
That's the correct answer.
Now you will see the decision tree. It's just a simple picture file. It's a PNG file. You should download that from our course content onto your computer, double click it and open it. You probably shouldn't do this on a cell phone. I don't know how well that'll work. Okay, so try to get a computer and do this. Your independent variable equals money. That's going to be measured in income. So is that continuous or categorical? Your independent variable 2 is going to be power. 1 to 10 scale on how powerful one's job is. Just you can actually look up how prestigious and powerful one's job is. Just sort of assume that. The important piece, that's a 1 to 10 scale. Is that continuous or categorical? Your dependent variable is happiness, which is yes versus no. And what test do I run? So that is your entry ticket for the day. The only entry ticket for today is use the decision tree to find out which test. Now, if you look at that decision tree, some things get complicated. And we're just going to make sure we go through a lot of different examples in class. That's all we're going to do is play around with our decision tree for the next few days in class. So what should you be able to do now that you couldn't do before? Number 1, use my decision tree. Number 2, define categorical versus continuous variables. Go review that. That's very important. Between versus within designs, review that. That's very important. We didn't practice it too much, okay? I just gave some definitions. I don't practice it on the lectures because you have limited time. So make sure you understand these concepts. Do your own examples. And finally, just number of conditions levels, but we've talked about that. Really review those other two and make sure you get those before you come to class.